Good evening, students. Welcome you to the first concept session on matrices, or otherwise we call the matrix algebra. This forms a very important chapter for board examination of class 12 because as we find every year the students find one 6-mark question based on matrices, kind of solving matrices, finding inverse operations, etc. So I am going to take you to the basic concept, take you right from the basic level. Today in this first session we will concentrate on the basic fundamental operations what you can do with matrices. And before going into the operation and type, let me just for a minute dwell on the concept of matrices. A matrix is nothing but an orderly arrangement of numbers or sometimes variables arranged in a proper orderly fashion. Today actually the matrices form part of computer science, and many of our students may be becoming data scientists in future. The data in computer system, it is arranged in the form of matrices. It may be generating a payroll for all the employees in an organization, or it may be a very complex arrangement of all the population, their so many things, their class, their income range, parents information, location, etc. stored by government of India. So whatever it is, we are applying matrices, the matrix algebra in various fields practically. So let us just find what is the how we can start with the basic operation. Basically the matrix, I can say it is made of rows and columns. We represent numbers or variables in a systematic rows and column. It can be as small as just one row and one column, which means I can put a variable here like this. This is already a matrix. So what defines a matrix? An orderly arrangement, and mathematically there is a symbol, there is a square bracket. The square bracket will get elongated or it may be enlarged as the size of the matrix may be. So there can be what is called row matrix. A row matrix simply has just one row, but the numbers in so many other columns. Columns, finite number of columns with just a singular row. As an example, let me write a row matrix. It can be, I am just writing natural numbers here. This is a row matrix. Try to count the number of columns, that is 1, 2, 3, 4 columns are there, but all of them in a singular row. Very much like row matrix, as students can guess, there is also the other counterpart category, column matrix. So you may represent a set of finite set of numbers or variables confined to one column, which means it can be made of, we call 3 rows. So let me name the rows as row 1, row 2, row 3. Similarly, in the row matrix, I can name the columns as column 1, column 2, column 3 and column 4. Now, in the next, as a consequence, students have to concentrate how to call the variable or address the variable, address the numbers mentioned in the matrices. For example, let me go for another matrix where I give a name for the matrix where there are 3 rows. I can call it X, Y, Z, P, Q, R. So what I have done here, as you can see, there are 3 rows and 2 columns. So basically what we need to understand, what is the order of the matrix. Order of the matrix implies the number of rows and number of columns which comprises the matrix. For example, in this case there are 3 rows and 2 columns. So I can say this matrix A is a 3 by 2 matrix. We read it as 3 by 2. So that is called order of the matrix, in which we write number of rows with the symbol followed by number of columns. This is the way we write order. From the order of the matrix itself, you will be in a position to understand the nature or the type of matrix. For example, let's go back to the row matrix. Row matrix, let me name it. So the row matrix X, what I wrote at the first, has, yes, you can see the order. There is 1 row only and 4 columns. So it is 1 by 4 matrix. It is a 1 by 4 matrix. And the column matrix what I wrote, let me name it. So the Y matrix has order. There are 3 rows and 1 column. Therefore we call it a 3 by 1 matrix. So by looking at this 1 here, you will be in a position to understand there is only 1 row. Therefore it is a row matrix. There is only 1 column. Therefore it is a column matrix. When we discuss matrix A, which is a 3 by 2 matrix, we know the length and the breadth or number of rows and number of columns are different. So we can say it is a rectangular matrix. So by the time already when I say rectangular matrix, students will guess, so sir, is there a square matrix? Yes, there is a square matrix. A square matrix has equal number of rows and columns. A square matrix has equal number of rows and columns. So naturally you expect a matrix to be like this. Let me go back for a 2 by 2 matrix. AB in row 1, XY in row 2. So this is a typical 2 by 2 matrix. I can write a matrix B, which is a 3 by 3 matrix. I am just randomly filling with some numbers, okay, which becomes a 3 by 3 matrix. Well, so now we have basically come to this level. We understand matrix is an orderly arrangement of numbers or variables in the form of rows and columns, and we have studied what is order of a matrix. Order can be simply a row matrix or a column matrix, rectangular as well as square matrix. Well, there are more types. So let us make a separate heading types of matrices. Already we have seen the row, column, square and rectangular. The two other varieties are the very basic ones. A zero matrix or null matrix. Students can easily understand that all elements are zeros in such a matrix. For example, I can make a 2 by 2 null matrix, or even a row matrix, 1 row and 3 columns, but full of zeros. That is your null matrix. Let us discuss next the diagonal matrix. When I say diagonal, I imply, or students must understand, it has to be already the prerequisite for diagonal matrix is a square matrix. Only a square matrix can possess diagonal. Not all the, for example, a rectangular, for example, in the case of 3 by 2, you cannot form a diagonal in this case. A diagonal essentially joins the very first element and the last element, and on the way you have so many other elements covered also. For example, here the 2 by 2, let me join. So the row 1, row 2 is joined diagonally as you do in the case of any kind of square. Similarly, let me join the other B matrix by means of diagonal. So you can see the numbers 2, 5 and 15 get connected along the diagonal. So the numbers on the diagonal, they are called diagonal elements. Diagonal elements. Whereas this is not possible in the case of a rectangular matrix. I may join. There is a number in row 1 connected. There is a number in row 3 connected. But you are not able to connect any number, any entry from row 2. So hence a diagonal matrix or forming a diagonal is simply not possible in the case of a rectangular matrix. So we presume the matrix has to be a square in order to make a diagonal matrix. A diagonal matrix has only the diagonal elements non-zero, all other entries or elements, I can say, happen to be 0. Well, some of you, the students may wonder, sir, what if the A or B or C, if it is 0, is it diagonal matrix or not? It is permitted, it is fine to have any one or even two of them to be zeros. If all are zeros, then you have already the previous definition, it comes under null matrix. Am I right? So in this case, A, B, C, one or more but not all entries permitted can be zeros. Fine, but still, as long as all other entries are zeros, we call it a diagonal matrix. We come to the next level of the diagonal matrix. What is that? Let us come to a special case of diagonal matrix, which is scalar matrix. Scalar matrix. In the previous case of diagonal matrix, I dealt with a 3 by 3 matrix. A 3 by 3 is a common entry in our class 12 syllabus of Cbse. So scalar matrix, again the prerequisite is diagonal matrix. So it is a unique diagonal matrix where all diagonal elements are equal and essentially all other entries are 0. I have made the diagonal elements, all of them, to be equal to A, again A, again A. That forms a scalar matrix. Proceeding this way, we can make a subdivision of scalar matrix. We understand all diagonal elements, if they are same, if they are equal, we form a scalar matrix. Suppose in the scalar matrix, if every entry is 1, for example, all diagonal entries are 1s and rest of the entries are 0s, so that gives what we name as identity matrix. So this matrix, which is a 3 by 3 order, the order is 3 by 3, made of all entries except diagonal elements 0s, diagonal elements made of 1s. This matrix is named identity matrix. Why is it called identity matrix will be evident or will be obvious to the students after studying certain operations with this matrix. Well, having said and done this much, I want to go to a different part of the foundation concept. How do we address the elements? How do we address the elements? Every entry in every matrix has its own address. So how do we address an element? So address of an element. Well, every student can easily see that the orderly arrangement of the elements in a matrix, when I say orderly, you can see that there is a prescribed row and there is a prescribed column. So when I say, for example, I want to highlight the number 4 here, the matrix B, which we did earlier, I am highlighting the 4. So when I say 4, we can see it is part of second row but lies in column 1. Lies in column 1. So I am writing here this element 4. It is part of row number 2 but column number 1. So take the letter which represents the matrix. It may be capital A or capital B. Now use the lowercase for that matrix to represent element. So the element 4 is represented as the lowercase alphabet which represents the matrix. Capital B represents matrix, lowercase represents element. Subscript will be the address. Row number followed by column number, you write in subscript. Now that represents the address of the element in the matrix. So very simple. So I can ask you what is the address of 15. So 15 happens to be in row 3, column 3, part of B matrix. So it is lowercase b, subscript 33, B33. Okay. So this is the way we write address. Now we go to the another concept of forming a matrix. Our syllabus, class 12, Cbse, expects a student to form a matrix given a discipline or a relation such as this. For example, forming a matrix. Let me write a question. Form a matrix. capital A, whose element Aij. Now students may be wondering, sir, what is that Aij? I stands for the row number, J stands for the column number, and the row address, column address will get updated when you move on from row 1 to row 2. I will change from 1 to 2. Similarly, when you move from column 2 to column 3, J will change from 2 to 3, and so on. So whose element Aij is given by. So they will give some relation like this: Aij is mod of I minus j. Let me stop here. Aij is given by mod of I minus j, which means, for example, if I say I is 1, j is 1, A11 is given by mod value of 1 minus 1. What more you think you require? Well, how many rows are there? How many columns are there? It is not clear. So it has to be mentioned. Given by, okay, and order 3 by 2, which means you have to prepare 3 rows and 2 columns. Totally 3 times 2, 6 elements you have to form. Under this discipline, or I can say under the rule or relation mod of I minus j. So what are the addresses you are going to prepare? There are 3 into 2, 6 elements beginning from A11. The row numbers, there are 3, but column numbers are 2. So first row, second column. When I say A12, it represents first row, second column. I cannot write A13. If I write A13, which means I am extending to third column, but the number of columns mentioned here is 2. So I have to stop here. The next element I have to then prepare. So row, whenever column number gets exhausted, you move to the next row. The next row is 2 with column address 1. With row number 2, you move to column number 2. In second row, you have exhausted column 1 and column 2. You cannot move to column 3 because such column does not exist. Therefore, you can move on to third row, column 1, and third row, column 2. You have already made up all the 6 elements. Addresses, when I say you have completed, writing the addresses is over. Now I have to evaluate what A11 means. So 1 for I and 1 for 2, 1 for j also. So 1 minus 1. The answer is mod 0, which is 0. Very simple. I minus j, so it is 1 minus 2. You can see how easy it is. Once you write the address properly in subscript, it's a matter of writing the first letter here and followed by minus of second letter. So it is 1 minus of 2 and mod value is 1. And here mod of 2 minus 1, which is also 1. Mod of 2 minus 2, which becomes 0. And what about here? Mod of 3 minus 1 is 2. And mod of 3 minus 2 is 1. Once we have calculated the values of all the elements, now you can frame the matrix. Now we can frame the matrix. Let me write here. So the matrix is named A. There are 3 rows. So make sure you have made sufficient space for 3 rows and 2 columns. Okay. Initially, if you want to do without error, I suggest students can with pencil or so, you can make entry here, row 1, row 2, row 3, you can keep a tab. You can keep a tab to follow that you have filled all the elements, positions, all the addresses. So column 1, column 2. So row 1, column 2 is filled with the first element 0. Row 1, column 2 filled with 1. Row 2, column 1, that is called 2, 1, which is 1, followed by 0, then 2, followed by 1. So this is how you can form a matrix, given the rule or the discipline you have to follow while framing the matrix. So make sure you evaluate the relevant elements, put them in place in the relevant matrix. So this is one simple example. I can go in for another example of framing a matrix. Let me just share a 2 by 2 model. So let us make a question 2. Form a 2 by 2 matrix A whose element are given by Aij is equal to. Let us make, for example, sine of I plus j pi by 2. Sine of I plus j pi by 2. Ready? Get ready. In your mind, prepare yourself to do 2 into 2, totally 4 elements. Prepare in your mind the relevant addresses, which is A11, 12, A21 and A22, nothing more. And not only that, when you say A11, you are going to put 1 and 1 here. So it's going to be 1 plus 1, 2 times of pi by 2. When I say A12, you are going to substitute 1 plus 2, which means 3 pi by 2. Sine value you are going to produce. So let us see how you are going to make up A11, A12, A21 and 22. Let us start evaluating. Sine of 1 plus 1, I am writing already the added sum here. Continue. Here it will be the sum 3. Here also the sum 3. Here the sum becomes 2 plus 2. 4. I plus j is 4 times pi by 2. Well, you already know the answers for every entry. It is an easy trigonometrical values of standard angle. Sine pi only, which is 0, sine 3 pi by 2, negative of 1, again sine pi 3 pi by 2, negative of 1, sine 2 pi gives you 0. Yes, students can now give the final answer. What is the matrix A, which is a 2 by 2 matrix A? What it is made of? Row 1 0, row 2 minus 1, row 1 is made of 0 and row 1 column 2 is made of minus 1, row 2 column 1 and row 2 column 2 made of minus 1 and 0. So that is the result of this manipulation evaluation. Once the address is given how to form Aij is given in the question, then what is it you do? You frame the number of elements in your mind, write the proper addresses and substitute that address I and j in the relevant expression given, evaluate them and compose them to get the matrix. Fine. In this session, let us wind up by with this arrangement of forming how to form matrix. In our next session, we will see what are the operations you can perform on matrices. Thank you, students.